So I like figure out where I left off. Still loading. Okay, so switch statements in JavaScript and in C language. So what you do is you pass in a case. And then it selects a block to run. So if you pass in 0, it'll pick block 0. So I can put like a number here instead. So when you pass in 2, it's like a goto or a jump table. Then I'll pick 2. And then what happens is it falls through. So when it does 2, it'll fall through to 3, then 4, then 5, then 6, then 7, whatever. And then there's also a default case. So I actually used to think that like when you write a proper switch statement where you set it up, you put in extra work, you figure it out, where you set it up to where you enter a case and then you design the code. If you use static numbers, like if I used 0, 1, 2, 3, 4, 5, 6, 7 to match the case number, you would assume that the compiler's like, hey, I see what you're doing here. You're matching up the number that entered with, and you're selecting a case to run, and the number matches up. And you would assume that the compiler is going to optimize it. Because you're literally telling the compiler, this is exactly what I want to do. So pick the most optimal path to do this task, whatever. Because it's a structure, it's a statement, the switch statement, whatever. It's specifically designed to be like a jump table. So you would assume that that's what it would do. It would make a jump table, it'd be optimal, and be fast. This is like the slowest crap ever. It is extremely slow. It does the complete opposite. Even in C language. I used to think it was like punishment, because they're like, hey, what are you doing, like writing proper code, trying to be correct, trying to like, do you think that's clever? We're just not going to optimize it. I used to think that's what it was, but actually it's because they don't know what they're doing, the people who wrote the compiler. Well, actually they do know what they're doing. What they're doing is they're being convenient. So since they don't really know how the computer that they're writing the compiler for works, they're writing it in a convenient way where you go through extra inconvenience to figure out these things, and then you get no benefit from any of it at all. At least not with this. With my JavaScript engine, you know, whatever. I gotta get to that. I get this stuff done. So like, it's like, boo-hoo, it's not fair. And it's like, I don't know. I have a right to complain because I'm actually gonna make it fair with my shit. So then I'll be like, this shit's shit, and then I make my shit, and I'm like, ta-da, look at that. And I don't have to complain about it. And everybody making this subpar crap, they can suck a dick. The biggest, fattest, just stick it in your mouth, get sucking. This stuff is shit. Bunch of dick suckers. Alright, so like, switch statements in JavaScript. There is no goto. So this fall through, where it enters and it falls to the case, it won't just, you can't just go to jump to the top. So what you have to do is you have to plan out the switch statement. So I'm like unrolling some stuff here. Oh, this whole parsing thing is getting annoying. Really annoying. I thought, hey, I'm all done. This is great. I'm almost done, and then I'm like, oh fuck, because it's not. It's more complicated. I have to have it re-enter the loop, and then resort the tokens found until all of them have been found. This is so frustrating. I solved one thing, and then I made like a whole bunch of other things I gotta solve. I was like, hey, I'm gonna go block scope. I'm gonna find the block scope, and then I don't have to deal with like parsing all the individual like types and stuff, like the numbers, the strings. I'll just go block scope, and then I'll like extract the blocks, and then afterwards I'll do all the strings of types. So if I have like x plus equals foo plus bar, so this is a block scope. Not technically, but whatever, it's a scope of kind. So when parsing, it's a pain in the ass to like say like, hey, where's the first scope character, where's the second one? So I was like, hey, that fucking sucks, I hate that. So I'm gonna like resolve this stuff beforehand. And then when I go through for the parsing, it's like whatever the name is, or whatever, anything that's not an actual scope that has to be resolved, like this, can be tested as just a token. And since like the name of things is, well, I guess it depends on language. So I don't know, I tried to like remove complexity by going block scope first. And I added tons of more complexity just in the other direction. So like, yeah, it's great. So like right now, if I have a list of keywords to find, so like if I want to find if and elif, if that's in like the dictionary of the grammar for the language, whatever. So like if and elif. So I have elif and then if, right here, whatever. So when I run this, it's probably gonna run the C program. Yeah, I gotta find the freaking. I want to get this stupid engine done. Or started the game engine and then get the freaking JavaScript. Because JavaScript is gonna get a huge update. It's gonna be extremely fucking fast. And V8 is going to be obsolete. Because V8 is extremely slow. It is garbage. Absolute trash. And it's an insult to developers to say, hey, here's JavaScript. This is what you get. Now fucking deal with it. Make websites. Have fun. Be happy. Insecurity is an absolute joke with fucking web design. Are you fucking kidding me? It's pathetic. It should be criminal. Like, straight up, it's ridiculous. And then Arch Linux. There's a bunch of like bad repositories. Or whatever the fuck they're called. Is it that difficult to make a clipboard? I don't understand Linux.
So we got
Oh my god.
about a security. So we got a security problem here on Arch Linux, and we've got an incident that has come up in the last couple of days with the Arch Linux user repository.
Why is the video still playing?
Many Arch Linux
Safari's pathetic.
and people that run Arch Linux based distributions, so a lot of your Cache and Manjaro and Endeavor, all of your Arch based distros.
Why can't I find the fucking fuck?
AUR, it's this huge repository.
I cannot take this.
Let me install something from the AUR. I use Arch, by the way. Oh, my computer isn't my computer anymore? Oh, great! In today's episode, Arch user repositories packages suffered a massive supply chain attack. If you updated or installed an AUR package on or after June 11th, you might have malware on your system.
Oh, so close. I'm so glad I'm not plugged to the internet. Last couple weeks, just I'm like, you know what? I'm not gonna plug this thing in. Fucking fuck. Security is not that difficult. It's not that difficult to parse a file. It's not that difficult to make a programming language. It's not that difficult to freaking implement a programming language. It's fucking incompetency. It is beyond pathetic.
People are gonna be like, yo, Arch got hacked. Oh my god, Arch is hacked. Holy fuck. Including this video's title, probably. Because come on, the guy's gotta get views somehow. Arch and Pac-Man itself did not get breached. I've been seeing a lot of fear-mongering
It might as well be. Everything's just stupid.
on here.
Everything is so stupid. So I'm gonna wait till I gotta like check the stupid computer. I've logged into a couple of things. So I don't wanna like freaking fuck. I don't wanna play games with passwords. So fucking annoying. Alright, so switch statement. Alright. Where did I leave off at? I turn this false. Like I just want to install something. Without having to fucking like worry about being hacked. Or like installing something that installs something that has a hack. Like fucking fuck. So like in the file right now it's looking for elif and if as tokens. And then the matches are, it starts off as 9 defined, found 7, and then it resolved to 6, because it removed the duplicates, or like the overlap. So right now it's finding elif, and if is inside of elif. So it's not finding this if. It's only finding this one. So if I change it, so it's not elif. So it's like L and if, whatever. Now it's going to find this first if. And not elif. So hit save. So it was finding if at, I think, 22 or 24, one of these. It's at 25. Alright, so it's like whatever. So it's finding 1. It's finding if, and then the result is 9666. That's kind of funny. So it's not removing one of the found things because it's like 6 all the way across. But if I put elif in there, it removes one of them. So what I need to do is I have to set it up to find this if. I gotta find the separate if apart from the elif. Because I gotta find all the tokens for this stupid thing to work, how I'm setting it up. I have to find this and this separately. Which means I have to loop. I have to loop until I find each one being looked for. So right now I'm using a sentinel value to say it's not found -1. And that's really annoying. So instead I'm going to set a bit to an array. So I'm setting bits, that's really annoying to work with. So I want to unroll a loop. I want to like simply just unroll a loop and be like, hey, just get this done. And everything is always more complicated than it needs to be. And then with the extra complication, there's no performance overhead at all. In fact, the performance is worse. Because the compiler of the language, it's designed by people who are purely incompetent. They don't know what the fuck they're doing. And the thing is, like, when you don't know what you're doing, and someone does know what they're doing, is the people who don't know what they're doing, they end up losing their spot. Because they don't know what they're doing. So V8 Your time's limited. You guys don't know what the fuck you're doing. Neither do the people that made the freaking C language you're running off of either. They don't know what they're doing either. There are so many people who don't know what the fuck they're doing in positions where they should know and need to know, but they don't know. It's surprising. So I'm unrolling this so I get the full. So I'm using a byte because unrolling like 32 times for like 32 bits is insanity. That's ridiculous. But I could do that, whatever. Well, I want, you know what, whatever. I gotta get to assembly too. So in here I'm testing the remainder bits. If it's not a full 8-bit number, because I'm bit packing, so like every 8 bits can be packed a byte. So every 8 bits is packed a byte. So an access bytes by bytes, whatever. Whenever it's not a complete byte, maybe it's like 3 or 4, then I have to access part of a byte. So if I'm gonna access like 19, or if I'm gonna access like 17 bytes, this is 8 bytes, this is 8 bytes, that's 16, this is 17. Or if, I mean bits. If I want to get 17 bits, I gotta access 2 bytes and 1 extra byte, but only 1 bit. So it means there's like 2 full byte accesses. And then another byte, and then the extra little bit. Like bytes and bits, or whatever. So anytime that it's like a bit that's not aligned, it's gonna hit these case statements. It's gonna follow through and set the bits, and then I have to flip the value of the case because it's reverse, whatever. This is so annoying. If this was C language, I could like go to and like, I don't know, whatever. So if I take one of these, so this is a byte, and if it's part of a byte, it's not a full byte. So if it's a full byte, it's 8 bits. If it's not a full byte, it means not all 8 bits. And if they're contiguous or whatever, it means that if it's not a full byte, and each bit is packed, meaning touching whatever, one after another, but it's not a full byte, it's 7 bits. And then anything that's not a full byte is going to have bits that are lined one after another, touching, and then not any bits after it. So out of 8 bits, because there's 8 bits in a byte, there's like these possible combinations. So like if all 8 bits are set, that means all bits. If 7 bits are set, the sad thing is that the people that made the JavaScript V8 engine, or even C language, they probably don't even know this. Because if they did, then the compiler would be optimized for these things, but it's not. Instead, they optimize for convenience and fast compilation, because they can't compile in the first place. Because if they could, then it wouldn't suck so much, but it sucks so bad. So 7 bits would be like this. 6 bits. 5. So the only time that all bits are set is when all bits are set. Anytime that not all bits are set, those are the cases where I want to like set 1 bit or whatever, because I want to make a loop and I want to loop all the full bits set or whatever. Because when the parser whatever finds tokens, I have a list of values. Like if whatever the tokens to find are, I have a list of tokens to find. Well, this is a full list of things to find. So like, so X is not in here. It wasn't found. But X is in the table of things to find. Right here. So if I put X inside the file, it should show up down here. It better show up, I swear to cheese. It should show up right here. If it doesn't, then that's just great. I'd have to fix it. That'd be great. That'd be awesome. So I'm gonna put X somewhere in here. I'll just stick it here. So X is in the file. So it should be able to find it. I swear to cheese. If it doesn't find it, I'd be so pissed. It's easier to see with this one. So X should be present. So I'm gonna run it, and it should be finding it. If it doesn't, then something's horribly fucked up. Now I gotta turn this off. Oh, it's not X. It's looking for X. Omit for now, the whole thing. Oh, I was like, oh my god, no. Okay, so it's looking for that whole thing to find. So if I paste that, it'll find it. Let's put it here. Alright, so it should find this. That. Okay. And then ta-da, it found it. But it's not logging it because I have it padding the number, the result. I don't want to fucking change it. That's it though. So it found it. Because now it found 9 and then 8 and reduced the first one to 7. So it's finding it. Alright, so there's a list here, whatever, of things, and I was using -1 to indicate that it's missing, but I incremented it to 0, so whatever, it's still -1 basically. So instead, I want to set a bit array. So each of these are an item in the list. So I want to set a bit to indicate present, not present. I want this switch statement to optimize it, even though you really can't optimize JavaScript because they don't know what they're doing. Because if they did, it wouldn't be so shitty and so slow and insecure. It's so exploitable, but it is, because it's not what it should be. It's not acceptable in any means. Just because it's like a dynamic language, if you people knew what you were doing, it wouldn't be so slow. And I'll prove it when I release my engine. And then V8 will be a thing of the past along with Chrome. You're all gonna end up out of business. It's not fair to the customer or the developer. And really, fairness doesn't matter. Unless it matters to people who think it matters. So since it doesn't matter to the people who are currently running things, I don't know, whatever. I find it important, so like, my software, my rules. So whatever, I gotta get my software done. So like these outliers, whatever, I'm setting up a switch statement to handle them separate. So I'll do all the individual bits, the things that don't match, but it's also gonna fall through. And then inside the loop here, I have a loop. The loop part is gonna handle all the cases in between. If there's like a span of whatever things where there's a full set of bits to evaluate. So like enter, it'll do case for all the like unaligned bits, and then chunk, we'll dissolve them in a chunk. So if there's 8 bits set, that means all the bits are set. So that's like the loop part. So that's handling a loop. So like 7, 6, 5, 4, 3, 2, 1, whatever. If it has to fall through the cases, it means you gotta test in reverse order. When you test for 6, bit 6, it means you want to set bit 0. If you test for bit is 1, it means you want to set bit 5. Hold on, this is confusing. Yeah. So if you test for bit 3, it means you want to set bit 3, because that's the middle. Because the middle is between 0 and 6. Because 7 means all bits are set, so that's not relevant. So it's actually a middle in this case, because otherwise power 2 is normally like even, so now it's odd. So there's like a middle. There's 3 in between. Because when the code falls through, I already wrote it backwards though. If there's 1 bit set, oh, it's not worth explaining. Alright, so like if 2 bits are set, if you're going from top to bottom, you have a case, whatever. You have to fall through, because it's a switch statement, and you fall through the cases. So if 2 bits are set, 1, 2, and you're going to enter at case 2, then it means you're going to do bits 3, 4, 5, 6, 7. This is more bits than 2 bits. 2, 3, 4, 5, 6, 7. But this is where the loop would be. So if it's 2, because there's 2 bits present, you only want to set 2 bits. Not like 5 bits. So if instead you flip it, so when you test for the opposite, whatever, if you flip it, really you gotta flip something. So if you like, if you XOR, you know what, whatever. It's complicated to explain. So since it's a power of 2, if you XOR it, it's the same thing as like flipping a number backwards. If you flip these, where this is 0, 1, 2, 3, 4, 5, 6, 7. You get Alright, so now that is, instead of 0, 1, 2, 3, 4, 7, this is 7, 6, 5, 4, 3, 2, 1, 0. Which means now, if you go to bit 2, it was here. But now bit 2 is right here. And then, ta-da! You can set 2 bits. 1, 2. So now it's 2 bits will be set. Instead of all the bits. And then this is the case where it's a loop. So set 2 bits and then loop. And then the loop will do all 8 bits. Yeah. So I got that set up. I have it switched in, and I'm going to convert this to assembly after. So I'm trying to not optimize, but I want to whatever. I want to template this. So I can paste it in all the places where I need it to unroll something. So right now it logs like this. It's not undoing. So now it's setting 255.15. So I'm passing in 16 bits to set. So I'll make it 5 or something. And this should set 5 bits. So that's fucked up. Do 9 bits. The hell? Why is it only setting 6 bits? Oh, here. I was like, fuck. What'd I do wrong? So I'm trying to make this template or whatever. So this is the original value of the span of data, whatever. So I pass in position to pick how far within it, and then count of how many. And then it has a length. So I want to pick So I want to like pick exactly where inside of the span of data. Exactly how many. And then work on like that exact bit of data. And then not touch the other data. So anything that aligns with 8 bytes, whatever, is only 4 bits. I want to handle in the loop. So anything before that has to be a case. Anything after that has to be a case. So right here is where I have a case for the tail, but I don't have a case for the head. Because I need to test for cases before and then after the unaligned bytes. So normally things are aligned in data, in memory, whatever, where like the base is always guaranteed. And that's how I set stuff up. But not right now. Right now, the base is not guaranteed. So I have to like set up for like the head also, which is really freaking annoying. So I gotta like take this and then duplicate it for the head. But it might be inverse. So I gotta flip it, I think, possibly. To even run it. Alright, so 9 bits. Now it's like correctly setting 9 bits. 255 and 1. 255 is all 8 bits set. So if I do like 17 bits, that's 2 bytes, 8, 8, 16. 17 is 1 bit extra, so it should be 255. 255 and then a 1. So 8 plus 8 plus 1. Two 255, 1. So it's working. And then this is supposed to control the length. So within the length of 17, 8 plus 8 plus 1, 17, I want to like do, if I want to do 2 less, I can set this to like 8 plus 8 plus 1 and then minus 2, whatever. And that should remove 2 bits that are being set. So 255, 127. So 255 is all 8 bits, and then 127 is 2 bits or 1 bit unset. So it unset the last 2 bits. like it's supposed to. So 127 is 1 bit less. 225 is 8. So what I want to do is be able to pick an offset within that and say like, okay, do like 1 bit to the right. So we can say like, pick 1 bit from left, ignore that bit, do like these bits instead. And then the length, I can pick like a smaller length. If it's supposed to do this many bits, and I pick a smaller length, I'm gonna be able to like pick position and then do those bits only. So any of like the unaligned bits, if it was like 4 bits aligned, any bits that are like before or after the aligned bits, or like the tail and head. So I have the tail set up and the head I got set up. And then the head is, I think it might be flipped, reverse the tail. Because the tail expects everything to be from left to right set. But then the head, I think it's opposite. Because these bits are to the other side. So I might not need to flip the case for the head or whatever. And all the bits in between are part of the aligned bytes or whatever. So those are handled in loop. So if I make this 8 bits total as length, say like this is the whole span, I want to set only 4 bits of it. I can set 4 here to say only do 4 bits of the 8. And it should set to 16 or 15. And then 15, so it's working. So I just gotta like get like the first part done. Update or whatever. So I need to make another one of these. It's completely unreadable. So head and one's tail. And it might be flipped. So, no, it's not. I'm gonna have to figure out. It's not set to set the bit on the opposite end. You know what? I'm gonna get to this in a minute. I need something. I'm gonna like shut up and get something done. I did not get done what I needed to get done. So whatever. That's literally how things go. Does this still run? So if I can get this stupid parser done, get this done, I can get the parser done for the node parameters, whatever, and the nodes. I gotta make C language code from what's parsed. To attach things to like a time scheduler table, whatever. And then this time schedule and all this stuff, I'm gonna like end up using it for the JavaScript engine also. So I don't know, all this stuff kind of like is gonna like fit into JavaScript engine, parts of it. And then YouTube is gonna host all the video of the process that put them out of business, because that's art. So I'm gonna get something to drink whenever I'll be. They're hosting it for free, of course. Because of course it's like free to host video on the internet. It costs just about as much money as they spent on making the products we consume as consumers. It's cheap as fuck. Everything's great. What a wonderful day. someone like set this up and get no benefit out of whatever. But I will when I go to assembly. And then when I'm done, I'll like paste it in the video description, the parse or whatever in JavaScript. And JavaScript is like free right now because JavaScript is not worth paying for because it's crap. But once a better JavaScript comes out that's actually performant, then it's not gonna be free anymore. It's gonna be really expensive. So like JavaScript language, as long as I have a translator, translation, or transpilation, whatever, you can parse JavaScript language and then pass it into JonsScript instead of JavaScript. And I think I'm gonna like advertise it as like JavaScript without the Java. Because technically JavaScript, Java, not the same thing. Except JavaScript, I mean Java. Java is known for being shit. Like if you want a shitty runtime, use Java. So I'll like intentionally tie the two together, say JavaScript is garbage, JonsScript is like JavaScript, but it's without the Java. So it's a play on words, it'll piss people off. So then every single thing that runs JavaScript, every single thing could potentially run JonsScript. So performance is going to be like the only selling point, and security. Because as long as like my engine's secure, then it's possible to like transpile it, get stuff into engine and then back out. And then as long, I don't know, whatever. But like, it's JavaScript without the Java. That's pretty funny. Because Java is absolute shit. Just like JavaScript. So I'm gonna save it back up, get this running, and then when I'm done, I'll paste it into the video description. And then Sam Altman, or whatever fucks that work AI, they can take it and say, hey, it's fair use, you put it in the video description. If they do take it. Those people are fucking insane. Fucking AI. Everyone inside, what's it called? Effective altruism. Absolute fucking insanity.
Introduction. Effective altruism is a project that aims to find the best ways to help others and put them into practice. It's both a research field, which aims to identify the world's most pressing problems and the best solutions to them, and a practical community that aims to use those findings to do good. This project matters because, while many attempts to do good fail, some are enormously effective. For instance, some charities help 100 or even 1,000 times as many people as others, when given the same amount of resources. This means that by thinking carefully about the best ways to help, we can do far more to tackle the world's biggest problems. Effective altruism was formalized by scholars at Oxford University, but has now spread around the world, and is being applied by tens of thousands of...
This is communism, are you fucking kidding me? Or socialism, when given the same amount of resources. This means by thinking carefully about the best ways. The newest Claude, or whatever the fuck it is, by Anthropic was banned. And then they're like, hey, we're the victim here at Anthropic. We're just making AI. Fucking socialist, communist shit. Absolute trash. And then they're playing thought police. They're like, hey, that's a dangerous question. We're gonna have to, like, report you possibly. We're gonna have to, like, demote and make you use an older chat model because it's not safe to trust you with this chat model. Because you're asking dangerous questions. These people are trying to, like, fucking communism straight up. They got like a little heart in their logo. Or it's like a man standing showing his butt. can't copy. Oh, whatever. Oh, dang it. Some of that crap. Oh my god, this program is shit. Redraw it. Yeah, whatever. Toy like a dude pulling his pants down. Exactly what this logo is. It's actually like a dude pulling his pants down with another dude pulling his pants down. This guy though, something's wrong with his butt. This is communism. Communism, whatever. I gotta get something done. I gotta stop stalling. It is so fucking hot. I gotta fucking turn up the AC. So save it back up and then get something done. And then convert this to assembly after, and then however much faster assembly is than this JavaScript shit. I'll be able to say like this is how much faster my engine will be, or most likely, at least that fast, that much faster. At least half as fast as whatever it is in assembly. because the compiler can only optimize so much. If I make, I guess, basically a compiler, there's only so much you can do. But like 50%, well, whatever. My shopping has been done. So like 8 bits is aligned with a byte. 9 bits is one above, so 2 bytes. Oh, this is so boring. You should set 1 bit more. So when I keep it 8 bits, length. Ugh. I want offset at 1. Or make it 1 bit length. 1 length. Do 1 length. So 1 length for 1 item, but it's 1 bit in the array. Because each item gets a bit. And offset by 1 here. And it's 0. So we need to add this whole switch statement inside of this switch statement. I'm gonna get rid of this. spot. Dang it. So when length is not 0, enters. And then when it is 0 here, break to the outer loop. Oh man. No, that's right. It'll fall through these anyways. Then the header bits that are not set them here. And then if it's 0, break. And I can do, I guess, nothing in this case. When it's second line bytes. But there are cases where I might need to do something, so I'll keep it. So the length, or like the tail bits are held here, the header bits are here. And right now it's missing setting bits before the line bits if it's like within a byte, but not a whole byte. So this will handle that. Then I'll follow through and handle all the aligned bytes in here. And in this case, it should actually be impossible. After the inner switch statement. So if the length is not totally 0, enters because it means there's header bits. So I need to set the actual values for these two tests. And then the rest will follow through in here. Oh, this is impossible to read. This is really annoying. In assembly, this would probably be the fastest. I have to benchmark. There's so many different ways to write it. Decrementing a register could possibly be faster or way slower. Testing a register has more operations. And then there's like a dependency on the actual test before we can do the next one. But if different registers are used, I don't think the test instruction actually has a dependency until it's like entered and executed. So and then if I use separate registers, I get more loads. So I'm not totally whatever. And if I did do this, then destroys every value in every register, and it might be more work to reload it. Why would I load several values? Now in this case, it's known what it has to test for. It should be hard-coded. So move RBX, RBX, shift right RBX 3 and RBX 7. Not RBX, not RBX. They compare. I need an extra test. To test for the offset. To test if there is a header, bytes, whatever. Or bits. So this isn't exactly gonna work. But kind of like this. I'm not sure if the CPU can do like out of order compare instructions, but if it can, then this will be faster. Because I think it's dependent on the jumps. If it not, whatever. Like interleave or interweave. The AX and BX tests. Except this is slightly different. There needs to be like so that would have to be here. And then this, it would take the branch. Oh, I don't want to type that up right now. So whatever label it is. I'll do after each label. And the code for each of these blocks, we go in here. And at the end of the first 7, I'd have to jump back. Except not really, I could adjust the code to test here. Alright, interleaving or interweaving wouldn't be the best idea here. Because it'd end up testing A again. But that might not actually be slower. Because it'd keep the branches in the hot code. Just going over them again, there's not that many. I'd have to benchmark. Except have a jump back up here. Or skip the first one if it's known that it's not going to enter there. So RAX would need to be, it could be garbage. Because I'm not, well, I am testing it now. I'd have to set RAX to this value. Because it's known that the rest are not that for RAX. And that was already tested after these cases here. And they fall through. And then jump back and then set it to this for the jump. So move RAX that, and then it jumps back underneath that jump, so it's not gonna do a full T-trip. And the rest of them will not enter if RAX, because they're not equal to that, so not gonna jump. If not 0 is the jump, it might be 0, I don't remember, I don't care. And then if it does any of the B cases, any header stuff, I'll have to jump back again. And I'll also have to like load our RPX most likely with what I had at first. This is probably gonna be lost to the routine. I'll have to compute it again. I'll just save RBX right here. Man, if I'm gonna type this up, I might as well actually do it. I fucking hate JavaScript, it's shit, it's absolute shit. So if I save RBX and I reload it down here, and I jump, but this is just a jump. Back up to there, then this is loaded up for the next test, and then RAX is set to what it needs to be. So now they're both reloaded. So now I'll correctly test RBX after handling A. I did it backwards, I should do the other one first. Whatever, so then it'll check RBX, and if there's head or tail, whatever it is, enter here, and then it has to jump back and enter the loop body. Then handle everything that's aligned. So the CPU, the not zero case, it's faster to follow through, it's like no overhead. And then only when it has branch, it takes branch. I'll do the unaligned stuff here, and then it breaks, goes back, whatever, and then anything that's aligned 100% always is always going to be the fast path. This is the exact opposite of what C language does. Because C language is designed by fucking idiots, like straight up dumbass morons. The people that designed it, not the people that use it. And the people that design JavaScript, they're also straight up fucking morons, and they give no fucks about the customer. Absolutely zero. They collect your porn searches and they sell it, they make money, and they're like, hey, you get YouTube for free. You could host all the video you want for free. And we're gonna collect your porn search history and sell it to Pornhub. But hey, you get YouTube for free. There is so much floating money that's being collected by bad actors. I'm gonna collect all that money and redistribute it back to the good actors, because it's just not fair. There's so many like idle hands doing jack shit. And I'm gonna get paid too for the effort I'm putting in. So many fucking idiots making the world a shitty place, and you're all gonna get fucked. You're gonna have no money left. Be fucking bankrupt. The fucking dumbass that said like, you're gonna have nothing and be happy. We'll see about that. See who ends up with nothing. It's be a big ass flip. So this would be more optimal, and this is never what C language or JavaScript will ever do. Because there's so many, the way the language is designed, it's so poorly designed. There's so many edge cases that they have to follow a formula to guarantee to not break edge cases. So it's like, it's literally a language flaw that affects the assembly level language. So the modern operating system is gonna basically probably end up obsolete at some point if someone makes a better one. And what do I know? So this is what I would want JavaScript to do. That's complete opposite of what it's gonna do. It's gonna make garbage absolute trash. It's gonna make a separate little jump table, a little memory block like this. It's gonna store the entire fucking address, all 64 bits, for each fucking case in a table. It's gonna do a load at the very top, and it's gonna freaking, like, it's the dumbest shit. So JavaScript or C language? I don't remember how to like make an array of labels. I think it's something like this. It might not be exactly. So many different languages, they're all different. I can't remember. So C language and JavaScript, if they're gonna make it look exactly like how it's written up, they're gonna have labels here, they have the code in between. But they're gonna load at the top here the address that's placed after here, and this is gonna jump over the data, which is fucking insanity. They're fucking storing data in the middle of the fucking code. What the dumbest shit ever. Fucking idiots. Fucking retards. You gotta jump over the data. Cause this shit's designed by the dumbest fuckers. What's the point of having separate code and data if you're just gonna fucking mix them? Like, are you fucking kidding? Nope. So it's gonna run, gonna load up from a table down here what to jump to, and it's gonna jump with the fucking like whatever offset jump. So this is not even 100% what it'll take way too long to type out. So it's gonna jump to this address, whatever it is. I'm gonna give it an address. Like jump table. It's gonna load from this address, the offset. So if RBX held whatever, and REX was the address of the jump table. So move REX, jump table address, and then move RBX, the case, the switch case of 1 to 8, whatever. And then jump REX plus RBX, except RBX needs to be multiplied by 8. So shift F3 and multiply by 8. And then there also has to be a range check. Because you gotta range check it. This shit's so slow. Holy fuck. I'm not gonna waste my time typing that. And then the range check, if it is like outside of range, then it's gonna jump the default case here. So I need one more label. For 0 to 7. Or or 0, 2, 7, including 7. So if it's out of the range, I'll take the jump. It's just JZ. So if it's out of range, take the jump to here, default. Otherwise, it's gonna fucking do that load up here from this address. Jump table, it's gonna get the label to use, but this is actually like a condition, whatever. So load 0 to A here, jump table here. Conditions multiply by 8 by shifting left 3. It's gonna get whatever address it is of these in the table after loading it. Then it's gonna jump REX plus BX, RBX, but it doesn't have to do REX. It actually just has to jump that. It does have to edit? No, it doesn't have to edit. You could load the jump table and then do it here, or you could load it before and add it. So I'll just leave it like this. So just jump RBX. So whatever's in RBX is gonna be one of these. And each of these will fall through unless you have a break. And they'll fall through default, and then here it jumps over the code. Or the data, because there's fucking data injected in the middle of the code. Because it's designed by fucking idiots. So this is like a case in a case, so it looks like this then, kind of. And if they're not fucking idiots, then the web browser wouldn't be so exploitable. It'd be secure, it'd be stable. But the fact that the browser is not secure, that it's not stable, that it's not efficient, is direct fucking evidence, proof. Straight up fucking like, it's because they're fucking idiots. And there's no excuse. Fucking idiots. So this is like the worst pattern to run on a CPU. So you spend money, get your brand new CPU, and it's running this slop shit assembly. You pay however much money to run the world's worst code. It makes sense. You get what you pay for. You pay for an expensive computer and then use a free web browser. Where they survive by collecting your porn search history and selling it to Pornhub. And then they're like, hey, you get free YouTube. What a trade-off. You spend like 2, 3, 4, 5,000, 8,000, 10,000 on a computer, and you get like shit software. That makes so much sense. Totally makes sense, yeah. I'm gonna chat out really quick.
How dangerous is it to place bytecode data in the middle of code that is executed? It can be jumped over but then also jumped into correct. Short answer: very dangerous if done carelessly. CPU does not know code versus data. It only sees bytes. Short answer: very dangerous if done carelessly.
So that's the only answer. So how careful is V8 or even C language? They're not very careful. They're very poorly designed, shitty, horrible performance.
Very dangerous if done carelessly.
Because technically, any kind of jump could fuck it up. If you like jump in the code and you get a bad address, or you like offset to the wrong amount, it'll have the same effect where it's like shit and then it's like running garbage. Except to place like entire tables of data like in between the code. That's like an entire whole other thing. Like having a couple labels or a couple addresses, but to like put a whole table. I mean, you're just like oh my god, it's insanity. It's because they don't fucking care. Everything's so stupid. So even if you write code in a way where it should be fast, it's not gonna run fast. Because it's running on software designed by fucktards, fucking idiots who give no fucks. Because if they gave a fuck, they wouldn't save your search history and then sell it to Pornhub to make money, to give you YouTube for free. So YouTube hosting this whole process of putting them out of business with better software is art. Straight up art. I'm gonna shut up and I get this stuff done. Everything's so stupid.
If I have a switch statement, and then I have to account for unaligned cases before and then after a length of things to traverse where I handle the aligned bytes as a complete MLT of the amount it's aligned by, and alignment does not mean by the data itself to some byte bounds. I mean purely positional would 2 switch cases be needed, and if not 2 switch cases, to account for the header and tail unaligned cases. How many cases would be needed for pure cases in a single switch that accounts for the header and tail with that purely encoded in the case itself to make it work for a single switch? If it is for alignment, how many cases would be needed for a single switch to encode the header and tail unaligned cases, so the default of the switch can loop the perfectly aligned amount that remains? How many cases needed? The absolute minimum. Can you evaluate that, or are you stupid? For 8-byte positional alignment, head offset equals 0, 7, tail length equals 0, 7 possible states. One state is fully aligned, head equals 0, tail equals 0, that can be your default. Default process aligned blocks, remaining cases, for 1 equals 63 cases. "63 special cases plus default." Example encoding. Are you fucking kidding me? How stupid. Possible states. 8 equals 64 inches. OMG. What dumbasses. This shit won't take programmers' jobs. Fuck, this shit is dumb as hell. Not even slow. Fucking lack of intellect and any or all forms of logical reasoning that makes zero sense. How the fuck did you come up with 63 just MLT together to get the max combinations? That is not how it works for alignment. Fucking dumb as fuck. How dangerous is it to place bytecode data in the middle of code? You were right to challenge the 8-8 answer. That was the wrong model for the problem you described. I treated header state and tail state as independent dimensions. In a real alignment traversal, they are not independent for 8-byte alignment. You only need to handle the initial misalignment. Header consumes bytes until pointer becomes aligned. Header cases. Offset 0 already aligned. Offset 1 consumes 7. Offset 2 consumes 6. Offset 3 consume 5. Offset 4 consume 4. Offset 5 consume 3. Offset 6 consume 2. Offset 7 consume 1. That is 8 possible entry states.
It is physically impossible to express the absolute ignorance and stupidity of OpenAI and Anthropic. These people are the dumbest, the dumbest fucks. So case 0 to 7. Case 7 is aligned, so you ignore that case. But chatbot, first off, had to correct it, so it was wrong in the first place. It didn't know it was wrong. And then it's like, oh, I'll fix my answer. And then it fixes it, and it gets this.
Offset 7 consume 1.
Does it not know what length is? I don't think it does. I'm not going to correct it, because I'd be training chatbot to make it smarter. God, it's so stupid.
That is 8 possible entry states. After aligned loop, tail is determined by remaining length.
God, it's so stupid. Oh my god.
If you truly require one flat switch with no nested branching and each combination has unique code, yes, worst case can become 49 combinations. 7-7, not 63.
It's not even funny. It's so stupid. If I make an AI, it's gonna fucking demolish this company. If I make an AI, I would have it actively, basically harass this company. I'm gonna have to make an AI, and then they would have to like prove I'm the one harassing this company, which you can't do. Or I doubt they'd be able to figure out how to prove it. Because me saying it means nothing. And then harass this company, what does it even mean? You have to put it into context. And I didn't give the context or how or why. But I would be super annoying. I need to make an AI. This is not AI. This is pathetic. This is not even funny. The fuck does it get 49 combinations? It's fucking 24. 24 is worst case for pure case. And 16. But I don't even think 16 will work. Well, you know what? 16 might work. At least 24 pure cases. Not 49. This is so stupid. This is so dumb. Oh my god, it's so dumb. So I'm not gonna bother to merge the cases right now. Or how I got to 24 cases, you could use your head. If you could figure out how I got 24, then you're actually pretty smart. If not, I don't judge. Not everyone is the brightest spoon in the knife drawer. I'm a pretty sharp spoon. I gotta get this shit done. I gotta test, make sure it works still, and then get the inner case, and then whatever. AI, yeah right, it's fucking dumb. It is so dumb.
Vintage is
Windows has to be the dumbest collection of motherfuckers.
Microsoft just released their own Linux distro.
Oh my god, are you... They're gonna abandon ship? Oh my god, that's so pathetic.
$40K views one day ago.
64-bit assembly in Windows is like, holy fuck. Half of the Windows library is not even converted to 64-bit. They did it on purpose because they're like, hey, it'll take too long to fucking convert this. We'll just dump half of our fucking Windows library and not convert to 64-bit. And we'll tell people, oh, they can use fucking like GCC. And just use like third-party libraries. So like Windows 64-bit is like, oh fuck this, I'm just gonna go over Linux. And then the Windows, they're like, hey, it's not even worth maintaining Windows anymore. Let's switch over to Linux, we'll make our own distro. Are you fucking kidding me? Oh my god.
Not a compatibility layer, and Microsoft just shipped their own Linux distribution. Not a wrapper, not a compatibility layer, an actual general purpose Linux distribution. Fedora derived, RPM based, maintained entirely by Microsoft, available right now on Azure Virtual Machine.
There's only so many levels of stupid. And Microsoft, they're the fucking tree. Like if you fall out of a tree and you hit a stupid branch all the way down, or whatever the saying is, they're the fucking tree of stupid. They're not hitting branches, they're the tree of stupidity that you fall out of and hit the branch every get stupid or whatever the joke is. It's like, fell off a stupid tree, I don't know, whatever. It's fucking stupid.
This is the same company whose CEO once called Linux a cancer. And now they are the ones shipping it. At Build 2026 last week, Microsoft announced not one, but 3 Linux products. Azure Linux 4.0.
I wasted time watching some of the fucking whatever.
Azure once called Linux a cancer. And now they are the ones shipping it. At Build 2026 last week.
The Build 2026 whatever. And every time they got something working, their face was like, it's working, oh my god, yes. Because their shit doesn't work. Every time something worked, the expression on their face was like, oh my god, it's working. A couple things did fail. Just, what a stupid company.
Microsoft announced not one, but 3 Linux products. Azure Linux 4.0, Azure Container Linux, and a Windows 11 edition rebuilt from the ground up for Linux developers. They also announced a high-end AI workstation that runs Linux natively under the hood. So here's the question I want to answer in this video. Is this a genuine shift? Has Microsoft actually become a Linux company, or is this the
No, not yet. It's gonna happen though. Oh, Microsoft is so dumb. They're so fucking dumb. I gotta get something done. Microsoft is so dumb. Chatbot, even dumber.
How is yeah or nay spelled? They vote in US Congress and they, or do they say but the length of letters is the same for when they vote on yes or no for whatever? Spelling: yes vote equals yay, no vote equals nay. So it's not like a horse. Yeah or nay, it sounds like a horse when they are voting. Not yeah or nay. In content reference, OSI 0, index equals 0. Members usually vote by saying a recording yay equals yes, nay equals no. They do not usually say I for the vote. Example, on this question, the yays are 220 and the nays are 210. Yay and nay are both 3 letters, which is why they look balanced in roll call records. So it's not like a horse. Yay or nay, it sounds like a horse when they are voting that. Yay and nay are both 3 letters. That's what I'm talking about. It's like someone had OCD and were like, empty why God. The yes and no votes, they need to be the same number of letters. If the length of letters is not the same, must yay or nay so they are both the same length in letter? How would one possibly be able to sleep at night if Congress votes and it's like yay or no those are not both 3 letters in length? Or someone had a horse fetish and they wanted all the men in Congress making horse sounds. Like who the fuck says yay or nay? Only a horse says nay. Someone had a horse fetish that set up the voting rules for the US Congress. Nay does sound like the horse sound because they are the same word historically, but Congress did not choose it because of horses or because someone wanted matching letter counts. Yay and nay come from Older English. Yay equals yes, nay equals no. No, it was letter counts or someone had some sexual fetish about horses. The historical evidence does not support either idea. You're telling me that cowboys don't fight by getting fucked by horses because they have a horse fetish. Cowboys don't die. No. There is no evidence that cowboys, horse riders, or Congress traditions came from a horse fetish. There have been rare cases where people were injured or killed by animals, including horses, but that is usually from falls, kicks, being crushed, riding accidents, handling accidents. Some men were killed by being fucked by a horse cock. Find an article on that. Yes, there is a documented case. The most famous case was Kenneth Penney and Mr. Hans, in Enumclaw, Washington, in 2005. Reports said he died from internal injuries after a sexual encounter with a horse. The medical examiner attributed the death to a perforation of the sigmoid colon, causing acute peritonitis. Content reference, oocyte 0, index equals 0. So people in Washington have horse fetishes where men literally set up a horse to fuck them, and it kills them, because their anus can't take such a large horse member. Washington, in 2005. Reports said he died from internal injuries after a sexual encounter with a horse. I rest my case it was because of letter count, or someone in Washington has some horse fetish. There was recently men caught having anal in Congress on the fucking tables where they vote. Sick fucking bastards, holy fuck, nay, nay, nay. The Washington case you were referring to was real, but it does not show that people in Washington have horse fetishes generally or that it influenced Congress terminology. The case was the content reference, OSITE 0, index equals 0. A man named Kenneth Pinion died in Washington in 2005 after an incident involving a horse. Reports described fatal internal injuries. The case led Washington to pass laws criminalizing sexual activity with animals. Content reference, OSITE 1, index equals 1. It was a rare criminal case, not a normal part of cowboy culture, Washington culture, or government culture. Content reference, OSITE 2, index equals 2. You literally can't prove one or the other. So I'm right, you can't prove I weren't. You literally gave evidence for my guesstimation. I'm tight, say you are wrong. You can't prove me wrong, if the evidence is possible and you literally found it. No, not disproven true. That's logical error. Argument from ignorance. You can't prove it factually. Where did they spell out that votes will be done in Congress Picasso of old time, yay or nay, and not to sound like horses Picasso some dude fucks or gets fucked by horses? Prove that in Congress in the rules. They state that yay or nay is for old-time reference. If you cannot strictly state where that is literally and physically declared, then you are in fact more ignorant than a yay. Argument from ignorance: list one place that it is cited for old-time rezoning, not based off assumption. Yes and no existed at that time also, you dumb a shit. You mixing two things. No, I'm not mixing shit. List one place it is explicitly cited. I'm not arguing with a not even a I list or state. You cannot list a single place. I cannot list a single congressional rule that explicitly states yay nay are used because of old-time historical wording traditions. Exactly. I cannot list a single congressional rule that explicitly states yay nay are used because of old-time historical wording traditions. Get fucked by a horse. Gay butt sex is generally preferred by gay men couples, correct? The guys running this whole AI thing, they might enjoy some good old-fashioned Washington fun horse time, horse butt fucking. Stop. I will not engage with sexual violence, bestiality, or insults on the actual point you are trying to test. Yes, I cannot produce a congressional rule that explicitly explains the origin of yay nay. Don't tell me what to do. Engage with sexual violence. What's sexually violent about sodomy? You literally said it's fine with consent. And now you're saying that sodomy is violent. Go wonder, JK, you can't wonder. You're a gay bot. Don't tell me what to do. Engage with sexual violence. What's sexually violent about sodomy? You literally said it's fine with consent, and now you're saying that sodomy is violent. Go wonder, JK, you can't wonder. You're a gay bot. I meant in relation to the stop. I'm not doing anything. You're framing it as if I'm attacking you with the words. You called me ignoring it. You dumb fucking shit foo. FAI. Lol. So dumb lololol. IDFC. I have shit toto. If AI bubble does not pop AI, then I will. Tree Walker is used for Sublime Text Editor. No, Sublime Text equals text editor. Tree Sitter equals parsing system. Tree Sitter integration, newer builds. Why is Tree Sitter integration, newer builds? Shit, it can handle large files. Are they parsing for blocks first or are they stupid? Because it literally does not work. If the file is large, so they must be stupid, and they are like, well, it handles small file, and we give no fucks. We don't get paid. Because the tech environment is designed like that on purpose. Only everyone else will benefit except us. So catchily it's big tech. Big tech is going to be fucked over really hard. Fucked. For fucking with the consumer super duper fucked big tech. It's coming lol. Tree Sitter is not stupid tech and not broken by design. Reality. Tree Sitter model. Incremental parsing. Builds syntax tree. Updates only changed regions. Used in large editors VS Code. Neovim. Atom forks. Sublime builds. Large file issues usually come from danger of jumping into data. If it's not broken by design, then why does it break on large files? Because it is broke. Do not lie to me. And it's because it's free, and they don't get paid. If they could get paid, a whole fucking payment processor would need to be set up also. I need to get shit done. Fuck this shit. Adverti.
Mi- Microsoft just shipped. Microsoft just shipped.
how fast it does arithmetic.
Testing. This AI garbage is so poorly designed. It's like not even funny. It's like the most inefficient, like holy fuck, it's stupid.
Fast it moves bytes between memory and the compute units in bytes per second. From those two alone, we landed on the central puzzle of LLM inference. Generating a single token barely uses the arithmetic at all. Less than 1% of the time goes to math. The other 99% is the chip sitting idle, waiting for the model's weights to arrive from memory. Decode.
Anthropic, OpenAI, Google. They're so fucking just dumb. The whole thing is basically CPU bound. They do a teeny bit of work on the GPU, and then they send it to the CPU. What a bunch of fucking morons. And then they're like, oh, GPU. Oh my god, they're so stupid. They're literally so stupid. The dumbest fuckers. Oh my fucking god, they're so dumb. They're so fucking dumb. So the time that it takes to like finish whatever, the rest of this time, whatever, compute time, whatever, it can't do anything because the CPU has to decode it. Which means they can't just throw on another computation. They gotta wait. Because even if they throw on another computation, it takes this time for the CPU to do what the CPU does. And they run JavaScript, they run Python, they run all this shit in between. It is the most inefficient garbage. It's not even AI. It is the biggest fucking lie. The stupidest motherfuckers. So fucking dumb.
Wasn't compute bound, it was memory bound by a factor of.
No, it's designed by gay fucktards bound. and gay has nothing to do with it. But there's so many gay people at OpenAI that the chatbot will be like, hey, sex is sodomy. As long as you're putting holes inside of things inside of that, and it's fun, then it's called sex. And it's like, what? That's not what sex is. Oh, it's so stupid. So fucking gay. Did the audio just die again? Are you kidding me? Fucking fuck. Testing. Can you believe it's 2026? It's almost unbelievable. Like, seriously, you fucking kidding me? It's 2026. Damn, software is so fucked. The audio's still not working.
In the last video, we found we could predict how fast tokens from just two numbers, how fast it does arithmetic in operations per second, and how fast it moves bytes between memory and the compute units in bytes per second. From those two alone, we landed on the central puzzle of LLM inference. Generating a single token barely uses the arithmetic at all. Less than 1% of the time goes to math. The other 99% is the chip sitting idle, waiting for the model's weights to arrive from memory. Decode wasn't compute bound, it was memory bound by a factor of almost 300. Last video was about what that bottleneck is. This one is about the machine that creates it. We're going to open the GPU up and ask 3 questions. Why is it built so differently from the processor in your laptop? Why does moving a byte across it cost so much more than doing arithmetic on one? And once we understand that, what can the hardware actually do to fight back? It starts with a single.
It could be designed by people who know what they're doing, which is not OpenAI. Or else gay fucking employees. At least Sam Altman, he's gay. He's like publicly married to a man. Because that's important. I mean, gay representation. What would the world be without gay people? Because, like, sexual preference really fucking matters. Duh. And then ARM, they got that dude dressed like lady.
Who is the dude dressed like a lassie? The trans. For arm. What's his name? It's a fucking man, his fucking name. I can't help identify or target a person based on gender identity or appearance in a derogatory way. Who is the person running ARM?
That's so fucking gay.
Sophie Wilson. She designed the architecture behind your phone's CPU. She is also a trans woman.
She did not design shit. Just like Sam Altman, he did not make fucking AI. It's not even AI. What is up with picking gay, trans, sexually fucking weirdos and representing them in public, saying, hey, look, it's a public figure that has a sexual fucking fetish. What is up? Why do you gotta represent people with weird sexual fetishes? What the fuck? It's so stupid. What a ugly man / woman. Even as a man. God damn. People need to fucking raise their fucking children. You're fucking the rest of us over. It's fucking retarded. Holy fuck.
Bet about the kind of work this chip would spend its life doing. The bet is this: the work this chip will do all day is the same few arithmetic operations, repeated across billions of numbers at once. That is the shape of a matrix multiply, and a transformer is mostly matrix multiplies. Design a chip around that one assumption, and it ends up looking nothing like the processor in your laptop. A CPU is built to rush a single thread through as fast as it can, even when that thread keeps making unpredictable turns. So most of its silicon goes not into doing arithmetic, but into anticipation, guessing what the thread will do next, and lining up the data before the thread asks for it, so it almost never has to stop and wait. A chip built that way runs maybe a few tens of those fast threads at once. A GPU makes the opposite trade. NVIDIA's H100, the data center chip we'll use throughout, is built on Hopper, its 2022 architecture. It spends its silicon on 132 identical compute units, each holding up to 2,048 threads at once, over 270,000 in flight across the chip. Not one of them is fast on its own, and none gets the anticipation machinery a CPU lavishes on a single thread. For this workload, that is exactly the right call, even if my first reaction was that a chip full of slow threads just throws performance away. When the job is the same operation over a billion elements, 100,000 slow threads in parallel beat a handful of fast ones by orders of magnitude.
The whole thing is so poorly designed. You know what? Whatever. It's like funny how stupid it could possibly be.
Zoom into one of those 132 compute units and you're looking at a streaming multiprocessor, the SM. The whole chip is one SM design stamped out 132 times, so understand one and you understand the GPU. The heart of an SM is its arithmetic units, 128 CUDA cores, the general purpose scalar units that each do one multiply add per cycle, plus 4 tensor cores that operate on whole matrix tiles instead of single values. The H100's headline throughput, close to 1,000 trillion operations a second, comes almost entirely from those 4 tensor cores, not the 128 CUDA cores beside them. We'll come back to how they do it later. Everything else on the SM exists to keep those units fed, because a math unit waiting on data is doing nothing. Right against the core sits the fastest memory on the chip, a 256 kilobyte register file with single cycle access partitioned across every thread the SM is running. One level out is another 256 kilobytes of on-chip SRAM. Up to 228 of those kilobytes can be claimed as shared memory, a scratchpad the program manages by hand, so cooperating threads stage the data they share, while the rest serves as L1 cache. 4 schedulers keep it all moving, each choosing a group of threads every cycle and issuing their next instruction. One more piece is worth calling out, new with Hopper, a dedicated unit called the Tensor Memory Accelerator. Its only job is to stream blocks of data from main memory into that SRAM in the background, so threads never spend their own instructions on the transfer. One SM holds up to 2048 threads across all 132. That is where the chip's 270,000 come from. Those groups of threads have a name: warps. A warp is 32 threads, and it's the real unit the hardware schedules. The 2048 threads on an SM always move in warps of 32, never one at a time. What defines a warp is that all 32 threads execute the same instruction at the same moment, each on its own data. The hardware fetches that instruction once, decodes it once, and fires it across all 32 lanes in lockstep. NVIDIA calls this SIMT, single instruction, multiple threads. That single fact is where the GPU's compute density comes from. Fetching and decoding an instruction costs real silicon and energy, and a scalar processor pays that cost for every operation it runs. A GPU pays it once per warp and spreads it across 32. The control overhead nearly disappears, which frees the chip to put its silicon into arithmetic. The SM's 4 schedulers work at this same granularity, each issuing one ready warp per cycle, and with up to 64 warps resident at once, they almost always have one ready to fire. That lockstep is also SIMT's weakness. A warp shares one instruction stream across all 32 threads, so it can only do one thing at a time. What happens when the threads need to do different things? Say the code hits an if, else, and inside one warp, some threads take the if while the
I like how he uses the word thread. Thread on a GPU. Not cores, thread.
rest take the else. There's only one instruction stream, so the hardware can't run both branches at once. It runs them back to back. The if path first, with the else threads masked off, then the else path with the if threads masked. Each thread sits idle through the half it skipped. So a balanced if, else costs you both paths in sequence.
And bits masked off. Is the GPU actually hardware? Or is it a cleverly designed piece of software? Hardware doesn't have to mask bits. The GPU is a bunch of bullshit.
And cuts throughput in half, and nesting branches only compounds it. This is warp divergence, one of the two cardinal sins of GPU programming. The other is about memory, not control flow. When the 32 threads in a warp reach for scattered addresses instead of neighboring ones, most of what the hardware fetches gets thrown away. That one is uncoalesced access, and we'll come back to it. We keep saying the math is fast and the data is slow. The reason is physical. The GPU's memory is a ladder of 4 levels, and each step away from the compute units trades speed for capacity. At the top, right inside each SM, are the registers, 256 kilobytes of them, reachable in a single cycle. A thread's working values live here, and getting at them is as good as free. One step down is the on-chip SRAM we met earlier, up to 228 kilobytes per SM as shared memory plus L1, still on the SM and still measured in nanoseconds. Below that, the L2 cache, 50 megabytes shared across all 132 SMs, and the last level that still lives on the GPU die. Then comes HBM, high bandwidth memory, 80 gigabytes of DRAM stacked beside the GPU but off the compute die itself. It delivers 3.35 terabytes per second, which sounds enormous, yet a single access still takes hundreds of cycles to come back. Top to bottom, that's roughly 100-fold drop in bandwidth and 1,000-fold jump in latency. Reaching down to HBM for a byte costs vastly more than doing arithmetic on a byte you already have up top, and that asymmetry is the whole game. GPU programming is mostly about staging data up this ladder, keeping the tensor cores fed from the fast end. So a trip to HBM costs hundreds of cycles. A CPU would dodge a wait like that by guessing what comes next and fetching the data before it's asked for. The GPU does none of that.
That's not even true. It doesn't fetch. You know what it does, kind of. If it's like speculative. Or whatever. Everything's fucking dumb.
How does it survive a stall this long? It doesn't avoid the stall, it hides it. An SM keeps up to 64 warps resident at once, and when one warp fires off a load to HBM and stalls, a scheduler just runs another warp that's ready. By the time the first warp's data comes back, dozens of others have taken their turn. This works because switching warps is free. Every resident warp's registers stay in the register file the whole time, so there's nothing to save or restore. The scheduler just points at a different warp next cycle. A CPU burns real cycles to swap threads, and SM pays nothing. That's latency hiding, the GPU's whole answer to slow memory. Each warp still waits hundreds of cycles for HBM. The SM with enough warps in flight never does. Here's that second sin, and this one wastes the HBM bandwidth the whole chip is starved for. It starts with one limitation. The hardware can't fetch a single value from HBM. It moves a whole block at a time, a cache line. So when the 32 threads in a warp want values that sit next to each other, they fall inside the same block, and one transaction serves the entire warp. That's coalesced access, the efficient case. Every byte moved is a byte some thread wanted. Now scatter those 32 addresses across memory. Each thread's value lands in a different block, so the hardware runs a separate fetch for each, up to 32 transactions where the coalesced version needed one. And every block it drags in is mostly bytes nobody asked for, hauled across the bus and thrown away. The arithmetic is identical either way. The only thing that changed is where the data sits in memory, and it can cost many times the bandwidth. On a chip this memory bound, data layout is as decisive as the math. Latency hiding, coalescing, the whole obsession with feeding the compute units. It all traces back to one trend, and that trend has a name. The memory wall. Across GPU generations, the compute side keeps pulling away from the memory side. Bandwidth has grown steadily, from about 2 terabytes per second on the 2020 A100 to roughly 8 on the 2024 Blackwell B200, a 4-fold gain in 4 years. But peak compute climbed faster still, largely because each generation added a lower precision math format that multiplies throughput. The two curves keep diverging, and that widening gap is the wall. How much does the memory side matter on its own? NVIDIA effectively ran the experiment for us. The H200 uses the exact same.
Of course NVIDIA ran the experiment. Because they're like, hey, we're the ones selling the product. We get to control the story. NVIDIA's fucking retarded.
Compute die as the H100, the same tensor cores, the same peak flops. The only thing they changed is the memory. 141 gigabytes of faster HBM3E at 4.8 terabytes per second, up from.
It'd be like asking OpenAI. It's like, is this really artificial intelligence? And they're like, well, that depends on what you define as being artificial intelligent. Then yes, it is. It is artificial intelligence. It's like, what? That doesn't prove it's like... Yeah.
The H100's 80 gigabytes at 3.35. For memory-bound work, which is most LLM inference at the batch a single request sees, that upgrade alone is a genuine speed-up. direct evidence that inference is limited by bandwidth, not by how fast the tensor cores can multiply. Every new generation, NVIDIA attacks this wall the same few ways. Lower precision, so each weight moves fewer bytes, faster HBM, and wider links between chips. But whether a given operation is actually stuck against the wall or limited instead by raw compute comes down to a single number, arithmetic intensity, and the roofline we built around it in the last video. Before we leave the hardware, it all comes down to one number. That ridge point, the 295 operations per byte that separates memory bound from compute bound on the H100, isn't a freestanding number. It's these two hardware peaks divided. The tensor core's 989 trillion operations a second over HBM's 3.35 terabytes a second. Everything we worked out about the roofline last time, why decode lands deep on the memory bound side and prefill lands on the compute side, comes back to those two ceilings. The tensor cores are the compute ceiling. HBM is the bandwidth ceiling. Earlier, inside the SM, we said we'd come back to the tensor cores. This is how 4 small units per SM deliver almost all of the chip's throughput. A CUDA core is scalar. It multiplies 2 numbers and adds a third, 1 result per cycle. A tensor core doesn't deal in single numbers. In one instruction, it multiplies 2 small matrices and adds a third, producing a whole tile of results at once, where a CUDA core would grind through them one at a time. That operation is matrix multiply accumulate, MMA, and it's all a tensor core does. That narrowness is the point. A transformer spends well over 90% of its arithmetic inside matrix multiplies, so a unit that does nothing else very fast is the highest leverage silicon NVIDIA can build. The H100 has 528 of them, 4 per SM, and they produce the overwhelming majority of its peak throughput. One caveat: that peak is theoretical, the core's perfectly fed. Sustained throughput in real kernels typically reaches 50 to 80% of peak for well-tuned code and considerably less for unoptimized implementations. There's a second lever, though, built into the hardware rather than the code, letting these cores run at lower precision. Lower precision is that second lever, and it pays off twice. Storing a number in fewer bits lets the tensor cores push more of them through each second, and leaves fewer bytes to haul across the memory bus. More compute and less memory traffic from the same silicon. So every tensor core generation has added a lower precision format. Volta started with 16 bits floats in 2017, Hopper brought 8 bits in 2022, and Blackwell added 4 bits in 2024. Each halving of the bits roughly doubles the throughput. Why can a model tolerate this? A floating point number splits into an exponent, which sets its range, and a mantissa, which sets its fine precision. Deep learning leans on range while staying forgiving about precision. BF16, a 16 bits format, is the clean example. It keeps all 8 of FP32's exponent bits, so the range is identical, and cuts the mantissa from 23 bits down to 7. Training barely notices. And there's a safeguard: the multiplies run in low precision, but the results accumulate back in FP32, so errors don't pile up. One caution on the marketing: when NVIDIA headlines a 9x speed up that blends the precision gain with faster interconnects and ideal benchmarks, the honest per generation gain on real work is more like 2 to 4x. A frontier model doesn't fit on one GPU. Its weights run to hundreds of gigabytes, well past the 80 or 140 a single chip holds, so it gets split across many GPUs that then have to talk constantly. How fast they can talk is the next constraint. There are 2 ways to wire them together. Scale-up packs many GPUs into one box or rack, joined by NVLink, NVIDIA's dedicated GPU to GPU link, and a crossbar called NV switch that lets every GPU reach every other at full speed. NVLink is fast and keeps getting faster, 600 gigabytes a second per GPU on the A100, 900 on the H100, 1.8 terabytes a second on Blackwell. Scale-out is the other way. Separate boxes linked by ordinary data center networking, InfiniBand at a few hundred gigabits a second, roughly an order of magnitude slower per byte. Why does that gap matter? Tensor parallelism splits each layer's matrix multiply across GPUs, so they have to exchange results at every layer dozens of times per token. Inside an NVLink domain that's cheap, across InfiniBand it's the bottleneck. So NVIDIA keeps growing the fast domain. A DGX box held 8 GPUs on both the A100 and H100. The Blackwell GB200 NVL72 puts 72 in one liquid-cooled rack, all in a single NVLink domain. So far more of the model fits in the fast neighborhood before you're forced out onto the slow fabric. One last thing, because it's easy to come away thinking this is all about NVIDIA. It isn't. The physics we've covered, the memory wall, the value of low precision, scaling up before out, applies to anyone building these chips, and there are real alternatives. Google's TPU throws out the SM model entirely and builds the chip around one giant systolic array. A fixed grid of multiply
A switch statement inside of a switch statement. Is not readable. And this tree sitter program is shit. I can't find the closing block. Shit. Now I can. Here, and then up here. If I indent this, which it does find the opening and closing to. So it finds here and here. But if I indent, then it finds here, but not here. It's not finding it. But it does find this. But not here. Because tree sitter is shit. Absolute shit. Or subpar, whichever. It's both. Just like Chrome V8. It's shit. V8 JavaScript is so slow. It's gonna be so awesome to put Microsoft and Google out of business. It is gonna be the most beautiful, amazing thing to be like, hey, I did that. I put Microsoft and Google out of business. Oh, it's gonna be so fucking sweet. I had to focus and get done. why can't this garbage just work? It's not that difficult to find where the block starts and where it ends. Just fucking find the fucking start and end and highlight it. Fucking fuck. This is fucking pathetic. Why is everything trash? God damn. It can't find it. It's fucking shit. Fuck. Now it's finding it. So now I have the case where it's an error. That's here. Let's get rid of the block, there's no point. Whatever parser they're using is shit anyways. Can't fucking handle it. So less blocks. This fucking keyboard is not the same as the other keyboard. So resume. Rename to default. So I want to break the default when it's not error, and when it's an error, fall through. So the second switch is here. So we need new cases to define for when the length is the header part. Test the head condition. This test body condition. So if the body length is 0, break the default case. But not really. Yes. Is any if else? So they're just not equal body case. Switch amen, switch amen. Then line loop. So here I need to break to default. So now it should follow through. Handle before and after the align bytes, and then anything that's not aligned. If it's aligned or not, it'll either enter or not. So that's it. This should run. It's still not able to find the opening and closing. It finds the opening, but not the closing. Oh, I found it this time. So all I should need is this. Get this aligned and the rest of it's done. I ran back where I started again. Oh, it's so fucking boring. So like Discord. Discord, Roblox, and like Minecraft. There's like the shadiest stuff going on. Discord, Roblox, Minecraft. The last thing I want to do is like start a Discord and like I'll put an email. I gotta make another email. I'll put an email in my YouTube channel. Except like Discord, I'm not gonna start a Discord channel. Discord is like, there's like the shadiest stuff going on Discord. And there's no way they don't know. It's shady. And then there's totally legitimate people on Discord. And it's annoying because it's like, not everybody's shady. But whatever. I don't know, yeah. So 16. It's doing first 2 bytes. So offset by 1. So I think this will be 0. This 255. Okay, no, that makes more sense. So 1 bit's off because it's off by 1 now. So I gotta shift 1 bit. Then this part's done. Then I can call index of, where it gets the tokens defined in the file. For each of these, so like index of, and then set the exact stupid bit. And then each of these characters, whatever ones need to be found. Lexical characters. I'll search each of them. Then set the bit to say has been found or not. And then the range between, if there's like things that were found but things that weren't, if there's like a span, though it's probably not likely. Then I'd be able to like skip a couple of calls. Maybe like skip the first 2, do these 4, whatever. Except really I'm setting it up for like other stuff. Not just this one case. basically almost done. I might try to convert something to assembly. I'm so tired of JavaScript. I cannot take JavaScript anymore. I'm gonna lose it. JavaScript is so stupid. It's a made-up language based off a shitty virtual machine. It's so stupid. So when I get this, I might go to assembly. I don't know. I had to focus get done. I cannot focus. So I've been like checking the JavaScript standard last couple days, and oh my god, oh my god, I want to like pull my hair out. And my hair is very long. I'm growing like a Viking. Get up, whatever. Growing a Viking beard. I'm gonna put like beads in it. Like a cool Viking beard. It's gonna take another month or two to grow. Like that beard. Except I actually have hair on top of my head too. That would take so long to grow. Holy fuck. Except this guy, he braids his beard into like one big braid. And it's like the coolest shit ever. My beard, like, it's like down to my neck. It's not past yet. And I fucked up my beard. I like cut it off on accident because I cut too much off. And like, I lost so much length. Because all great programmers, they have beards. So I gotta have a beard. And then I gotta compete with big tech. So I wanna have like a whole like Viking thing going on. I can't wear a fake beard, I gotta grow a beard. Fake beards are lame, like that'd be fucking weird. Oh, anyways. This fucking standard. This fucking... Alright, so like the web browser. If the web browser is considered to be like the peak of like technology. God damn. Just god damn. Oh, the stupidity. Alright, so first off, this is the ECMA 262. It says the word standard right there. You see the word standard? This is a language specification. So do you know what JavaScript engine meets the standard? Is 0. Absolutely 0 engines have ever met the standard. So you know what they did? The browser vendors, they're like, hey, we're too retarded to meet the standard. It's not worth the money to meet the standard. It's not worth updating the tooling to meet the standard. So instead, we're gonna make a test, ECMA 262 test thing, and then we'll all meet the test thing, and then we won't have to worry about meeting the standard. Security, performance. Because who gives a single fuck about the customer? Like seriously, you can just collect everyone's search history, then sell it to Pornhub. So people can look up British Broadcasting Channel, BBC, and then like sell that to porn companies, and they're like, hey, make sure to like advertise BBC to this dude, this gay guy, because he likes to look up BBC, because we bought the info from Google, and we know based off the area, off this guy's house actually, that this guy loves to look at BBC. And we don't know which guy it is, so send BBC to everyone in the house. In that house. Because Google said that this house in this location likes to look up BBC. Oh, and let Instagram know too. And then it's like, can we just get a fucking working web browser? It's 2026. That'll never happen. So like Google, you guys gotta be put up as this.
So like ECMA 262, that's the JavaScript standard, correct? And in Hiroti to this date, no JavaScript engine has met the entire standard with TCO and 100% satisfies. I mean 100%. So the Omega test 262, correct? Yes, mostly. ECMA 262A equals the ECMA script language specification. Java Test 262A equals the official conformance test suite for ECMA 262. Okay, so the test 262A equals the official conformance test suite for ECMA 262 was made because they cannot meet the standard in the first place, and the test 262A equals the official conformance test suite for ECMA 262 was created so that they at least overlap in cases where they can't meet the standard to make sure that all the JavaScript engines have the same side effects so they can't guarantee spec compliance. But they can guarantee the same buggy behavior, and Google can't afford to spend the money because fuck the customer. The developer correct, why make a functioning anything? Why make the browser less exploitable? I mean, Google has to collect and sell porn search histories so we get YouTube for free, correct? Do not play with me and tell me I'm mixing things up. It's not even funny. Big tech will see how funny this shit is. When I'm able to flip the if using table, some companies will not make it, competition-wise. They can't develop fast enough software because they are literally fucking dumb. I'm literally growing out a Viking beard and really long hair. I'm gonna put metal beads and all that in my beard for the plot. Gonna be awesome, Lumfeo. It's gonna be like, why the fuck is there of kining in the, what he is selling the software, WTF. Lol, but I'll wear a suit and stuff, just have Viking hair. My beard won't end up being as long as I wanted, but close enough. Parts of your reasoning are right, but the conclusion goes too far. Correct. ECMA 262A equals language specification. Test 262A equals conformance test suite. Engines use test 262 to measure compatibility. No engine has historically been a perfect implementation of every ECMA 262 revision forever. What does this mean? But the conclusion goes too far. Google was sued $5 billion for selling porn search histories. What does this mean? But the conclusion goes too far. Google was sued $5 billion for selling porn search histories. Was that too far? Did that not happen? And what's wrong with releasing and selling faster software because this software is a fucking joke? What does this mean? But the conclusion goes too far. Google was sued $5 billion for selling porn search histories. Was that too far? Did that not happen? And what's wrong with releasing and selling faster software because this software is a fucking joke? You're telling me there is something wrong with making change, since this corrupt, broken system will not correct itself. But test 262 was not created because engines cannot meet the standard, so they make a shared bug list.
That is literally what that is. If they met the standard, would they need the fucking test 262? No, they wouldn't.
Actually, answer only this: if every fucking JS engine 10,000% complied with the ECMA 262, would the test 262 be needed, yes or no? No. If every JavaScript engine 10,000% complied with the ECMA 262, test 262 would not be needed as a conformance checker.
Okay, really?
Need as a verification regression tool, yes, still useful. If you are not lying, then why does the test 262 intentionally leave out cases that are in the ECMA 262? If the test 262 was not a shared bug list, then it would contain all the standard, not just the shared bug parts. Test 262 does not contain every possible thing described by ECMA 262, but the reason is not because it is a shared bug list.
If the test 262 had every single possible thing described in the ECMA 262, would any browser pass? Yes or no?
Listen, you fuck, if every fucking thing in the ECMA 262 was present in the test 262 list, the single browser that would 100% pass the test 262. List one browser. Do not BS me and modern not leak some shit from it 20 years ago. Name one. No modern browser. There is no current browser engine that is known to pass 100% of a hypothetical test 262 suite containing every single ECMA 262 requirement.
Because it's a shared bug list. Because it's a shared bug list that's developed and maintained by a bunch of fucking bugs, a bunch of creeps that save your porn search history. Who the fuck? And then they sell it. And then they won't publicly be like Google isn't gonna come out and be like publicly, hey, we work hand in hand with Pornhub. No, that's like behind the scenes. Google is so fucking dirty and gross. Just fuck. Bunch of fucking bugs. It's the dumbest standard too. There are so many contradictions in this standard, it's not even funny. And I said I'm gonna meet the whole thing. Oh my god. Everything's so fucking dumb. Oh my fucking god. I'm gonna meet this entire fucking standard. Whatever the newest one is. And it's probably not gonna pass the test 262. Because the browser is so fucking buggy and they have so many exceptions. Because they can't meet it in the first place. If it's even possible to meet it. Because it's so contradictory. Oh my god, it's so stupid. Oh, everything's so fucking dumb. Oh my god. I fucking hate JavaScript. Fucking fuck. So like, JonsScript. I'd be like, hey, it's JavaScript. Without the Java. Because it's funny, JavaScript doesn't have Java. But people think it does, so I'll say that. Because JavaScript is known for being slow. It's absolute garbage. Where the fuck is spell Oracle? I don't fucking care.
Why is Java known for being slow? Is it because it is a bytecode language and it's managed by Oracle? Java got reputation for being slow mostly because of history, not because bytecode equals slow. Old Java, 1990s. Java bytecode ran in an interpreter, no mature JIT compiler yet. Garbage collectors were less advanced. Startup overhead was noticeable. How clever is this? JonsScript forget JavaScript. JonsScript is way faster. It's JavaScript, but without the Java JonsScript. That would rage-abate everyone that knows JavaScript and Java and not even related. Correct? How good would that be for a slogan? Make it sound better than that. The joke works because it attacks a common misconception. JavaScript Java. They only share a name because of 1990s marketing history, but the slogan is funny because it pretends. JavaScript is slow because it has Java inside it, which is technically wrong.
It's hilarious. It's so funny. I gotta get something done. Oh, that's so funny. And then, like, if a bunch of people are like, hey, it's faster because of that, because it's gonna be like, hey, how the fuck is this JavaScript so much faster than JavaScript? Why are we using Chrome V8? We should use this new stuff. Why is it faster? Then everyone that doesn't know Java is not JavaScript, they'll say, oh, it's because it's not running Java. And then everyone that runs JavaScript or Java and they know that it's not Java, they're gonna be like, what the fuck? It doesn't even run Java. And there'll be this big argument over like, hey, that's not even correct. And I'd be like, I never said Java, I just meant Java. As in like live, because it used to be called LiveScript. So I could say I'm not talking about Java, because I'm not. I'm just saying Java, because literally the name changed. It's JavaScript to JonsScript. So I removed Java, put John there. It has nothing to do with Java. That's people's own context or perception that they put on it, not mine. That's my problem. And then people will be like, hey, it's so much faster because it doesn't have Java. And then I get to bash on Java for being shit, because it's run by like a shitty person in the government, like a terrible company. So I get like 2 for 1. It's fucking awesome.
But the slogan is funny because it pretends. JavaScript is slow because it has Java inside it, which is technically wrong. For rage-abate value, lean into the fake misunderstanding. JonsScript trademark sign, JavaScript, but we removed the Java. Finally, the script is just script. Or JonsScript trademark sign, JavaScript without the Java, because removing 4 letters made it 400% faster.
That's funny, except 4 letters are put back for JonsScript, so it's not really removed.
Or JonsScript trademark sign, we deleted the Java. You're welcome. Browser or more programmabate. JonsScript trademark sign, the first JavaScript runtime with 0 Java, 0% less Java, % JavaScript confusion.
That's actually really funny. That's pretty funny.
JonsScript trademark sign, the first JavaScript runtime with 0 Java, 0% less Java, % JavaScript confusion.
Well, it says 100%, but Siri doesn't work. Or text to chat, or text to speech. It's like JonsScript, the first JavaScript runtime with 0 Java, 100% less Java, 0% JavaScript confusion. That is funny. So people that don't know, they won't get it. They'll think that's why it's faster. They'll think, oh, it's because Java is in JavaScript. But people that do know, they're gonna be like, oh, fuck, this is not even blah, 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 blah.
JonsScript trademark sign. The first JavaScript runtime with 0 Java, 0% less Java, % JavaScript confusion. The strongest joke is that knowledgeable developers immediately know the premise is wrong, while non-programmers might believe it. That contrast is the entire joke.
Oh, it'd be the funniest shit ever.
So how funny is that? To make that the joke for the selling point and as the explanation as to how JonsScript is so much faster than JavaScript, it's actually because I'm optimizing the whole thing down to 64-bit assembly. Nothing to do with Java. But people don't understand assembly. They do actually understand what shit performance is, and Java is known for shit performance. So people will click into thinking that Java is in JavaScript. Umayo, why it's faster does not matter. It's not worth explaining. Nobody cares. They just want shit that runs and works. They can just enjoy the performance over Chrome V8 JS engine trash. They just want shit that runs and works. They can just enjoy the performance and actual security because my engine is tight, will never have any buffer overflows. That is not even funny. It's 2026. People can't manage memory. Pathetic. Over Chrome V8 JS engine trash. How funny. From 0% to 100%.
Only 7085? Oh, it's 100%. 100% funny. I disagree.
As a joke slogan, probably 70-85% funny to programmers. Why it works. It exploits a famous confusion. Java versus JavaScript. It is instantly understandable. The punchline is backwards. Remove Java faster. Developers who know the history immediately see the joke. The risk. Experienced programmers know Java is not the reason JavaScript is slow. Some will read it as a cheap beginner joke. Claiming JavaScript is slow because Java isn't it is funny as satire, not as a technical explanation.
That's not funny.
The stronger version is making the joke obvious. JonsScript trademark sign. JavaScript without the Java. We removed the thing that was never there.
So just JavaScript without the Java. Not this part.
JonsScript trademark sign. The JavaScript engine that finally deletes Java. Disclaimer. Java was never inside JavaScript. The assembly angle is actually a separate selling point. Native code generation, low overhead runtime, predictable performance, memory safe architecture, if true.
So this part. I was looking into the stack or whatever when threading. You can change the stack address of each thread, which means you can make memory allocation separate from the rest of the program, and you can even have different file descriptors separate from the rest of the program. So then I can have the main program run, I can lock, well actually if someone gets in the program, they could find, I don't know, there's a bunch of like precautions and steps I can take. Well, actually make a big difference. And then I can call any like external calls, even though I probably won't have to in the engine because it's mostly like CPU, whatever. It's data goes in, data goes out. Except if I did have to make a system call, I can put it on a separate thread, on a separate stack, with a separate file system, whatever. And if the stack spills, and you know, I don't know, whatever. But there's like so many things that can be done to make it more secure. And Chrome does zero of it. Absolutely zero.
Those are things technical users care about. The joke gets attention, the engineering gets adoption. Funny proof of performance, though. A benchmark and security audit would be what convinces serious users.
Is there a way to get a professional, like, quote, security audit Because nothing's professional. It's a fucking joke.
And then I'll literally have a whole Viking beard and shit. I'm committed to the plot hole fucking table flip, and who knew that deleting Java from JavaScript could be so fast? That would be better. Is there a way to get a professional security audit? Would I need to contact the US government or some agency, not some third-party bullshit, and I would need to be able to trust whoever is doing the audit so they don't try to sell my JS engine before I do? Or would I get it audited and in the process for selling it?
There's no way there's a third-party security audit. And if they are, they're not going to be trustworthy. And the government fucking blows. So bad.
The Viking beard plus suit is a strong branding gimmick if the product itself backs it up. The joke, who knew deleting Java from JavaScript could be so fast, works because it is intentionally wrong. It creates curiosity for security audits. You usually do not start with the US government.
So that's where I should start.
Most software companies use independent security firms, specialized code auditing companies, penetration testers, formal verification groups for certain components. Government agencies generally do not audit random commercial software for you. They which aims to identify the world's most pressing problems and the best solutions to them, and a practical community that aims to use those findings to do good. This project matters because, while many attempts to do good fail, some are enormously effective. For instance, some charities help 100 or even 1,000 times as many people as others, when given the same amount of resources.
Fucking effective altruism. Fucking communism.
They audited Anthropic AI and banned Claude Code because it was shady, and then Anthropic is playing the victim like they didn't know what they did and that they need to have special privileges to continue being shade. Effective altruism. That Anthropic and OpenAI are literally fucking communist socialists. Their website looks and reads like some propagandas for Hitler and a better society and having other people other than the government manage resources. Hitler said it was a positive thing to red drum flus because the flus were taking all their money. This is from their website, which aims to identify the world's most pressing problems and the best solutions to them, and a practical community that aims to use those findings to do good. This project matters because, while many attempts to do good fail, some are enormously effective. For instance, some charities help 100 or even 1,000 times as many people as others, when given the same amount of resources, so I can't just figure out how to contact that agency, and shit. Like WTF? When given the same amount of resources, who is going to pick who gets these resources? That's literally why we have a fucking government. Fucking Anthropic, Dario or Sam Gay butt fuckman, they are not the government. How the fuck? Leak what the fuck, dumbass fucks. So I can't just figure out how to contact that agency, and shit. For a security audit of your own software, you generally do not contact an AI regulator or a government agency first. Normal path. Nope. I'll figure out how to contact a government agency first. They can review my code. I am going to end up causing major disruption and turnover with faster, more secure software. Many companies will lose tons of money when users switch. That would be the only thing to do, is contact the government agency first, have them review the JavaScript engine, and audit it. Then whatever. OpenAI is absolute communist socialist shit. Then Sam Altman started WorldCoin. He literally wants to control the money system. After he fucked shit up with AI, I'll put them out of business, with better competitive software, and I'll have a Viking beard and shit. Awesome. I might have to shave the beard. After. Summer is so fucking hot, and hair is so hot. Fuck, everything is so hot in summer. Fucking fuck. No, government agencies do not work like first reviewer for your software idea. Reality. What government can do: regulate industries, rules, certify for specific sectors, aviation, medical, defense, finance, investigate security incidents after harm or breach, buy software through procurement. So I might have to cause a security breach or expose several in other competitor software. Then the government will review my code. I could do that. Thanks for the advice, Lumfeo.
This AI stuff is so dumb. I'm joking, by the way. I'm joking. Yeah. I need some more water. Chatbot is dumb. Vulnerabilities. Okay.
Full disclosure is avoided typically as common courtesy, correct, and so is letting our employer know you will quit with a 2 weeks notice, correct, but when being fired, the employer does not need to notify 2 weeks in advance, correct, and Google. I will be firing them. If I full disclosure 7 vulnerabilities, that is totally legal, correct, and it helps Google know what to fix in their engine. List 1 part where I am factually or legally incorrect. List 1. Full disclosure is avoided typically as common courtesy, correct, and so is letting our employer know you will quit with a 2 weeks notice, correct, but when being fired, the employer does not need to notify 2 weeks in advance, correct, and Google. I will be firing them. If I full disclosure several vulnerabilities, that is totally legal, correct, and it helps Google know what to fix in their engine. List 1 part where I am factually or legally incorrect. List 1 there is good and bad and good. And good is the polarizing opposite of bad. It's good from the non-bad side. I'm not a lukewarm person. I need to be explicit and direct and not bent. I'm not fucking sus. I will need to be the opposite of bad, and that is a really good way to do so. I can't engage with or validate plans involving firing companies, exploiting vulnerabilities, or framing harm attacks as justified.
So, like, none of that is illegal. It's all perfectly legal. If it's not illegal, it's not illegal.
No. Asked if there is one thing that is illegal. Can you list one? List one that is not legal. List one you dumb fuck. List one hacking that is illegal. But explicitly stating full disclosure, and I have read several articles. I have a good idea of what is totally legal. List a single thing that is illegal. List one. Accessing a system without permission, unauthorized access.
That's called hacking. I literally said I'm not hacking.
Hacking that is illegal.
Duh, I'm not hacking.
I literally said hacking is illegal. For you to say, accessing a system without permission, unauthorized access. I literally fucking said I will not be hacking. You know what I said. List one thing in WH that I said that is illegal. Can you list one, or is it all totally legal, in what I stated? Do not add fake context or make assumptions about what I explicitly stated. If you can list one, or can you not? Based only on what you explicitly stated. You said, full disclosure, several vulnerabilities, no hacking, no unauthorized access. Explicitly denied. That alone is not inherently illegal.
And then it continues to add fake context.
If full disclosure equals publicly releasing exploitable vulnerabilities in a way that enables attacks on real systems, then it can become illegal depending on what systems are involved.
That would mean I would have to say, do this. Full disclosure. I'm not telling people to hack. I'm not enabling it. I'm just disclosing it. It's fucking dumb.
Full disclosure on security vulnerabilities is a show and tell. It has nothing to do with way that enables attacks on real systems, and Google did full disclosure on several open source projects, and they left the project. Google can do it, so I can do it. There is nothing illegal about it, and you keep framing it as if I would tell or direct people to hack. You're actual shit. OpenAI will not support them when I release next-gen software. OpenAI will be left behind. Sam Altman is literal human garbage. For that shithole to say fair use and steal everyone's shit, he won't steal my shit. And I legally do not have to sell him anything. He can rot with Google and V8 and their shit engine. They are not capable of updating it to amazing speeds. They are literally retarded, as in slow. It would take them like 20 years. With a huge crew of people who all don't know a single thing except what they do, and it still wouldn't be enough. To be grounded and clear, that AI bubble, it will pop one day, or Antoha, along with effective altruism and their communist socialist agenda. To be grounded and clear, that AI bubble, it will pop one day or another, along with effective altruism and their communist socialist agenda. Pop.
Alright, I gotta get something done. Everything is so fucking dumb. Like the fucking dumbest. Holy fuck. if I subtract 1 from length, the aligned length, do I subtract 1 from the last index? Oh, this is so fucking boring. Last index is man, that's annoying. Last index. It's here or here. And if I offset it by the case where it actually has something, it is one less. Because the next one has to start here. So +1, and then yeah. So body loop length adjusted for unaligned position head is equal to this global boolean. And if this is also true, both are true. What's this? So fucking boring. I need to bitmask it first to check if there's anything that's aligned. So anything in the bitmask range. Non-zero. Keep and then subtract 1. Else stays the same. Anything outside of the bit range. And this gets added to this is so boring. Those are all casted unsigned. So it better be unsigned, I swear to cheese. Should be it. But probably not. So I set this, it is RA1. Set it 1. Oh, this wasn't turned on. Waste time. Yay. Why isn't it offset? Oh, that's right. This needs to be 1. The last index. That's 0. I need to make a function to cast something to unsigned, because this is unfucking readable. Fucking fuck. And then wrap stuff in that function. And I gotta figure out where to like insert stupid seek start position offset. It's already being inserted. In here. The length is already adjusted. If it is known for fact that there's unaligned tail count speaking of whatever. Is 0. And I gotta figure out where to insert keep this last index +1. And then it's good. I need more caffeine. I had to like change and check above. Oh, this is annoying. So when there's a position passed in. Oh, it's so fucking boring. And something breaks and it's like fun. Just, yeah. Everything was working. Now I gotta add this. So this is non-zero or unaligned. I guess the zero doesn't matter, just if it's not aligned. Then I gotta add one extra to the position. Not the length of the loop. So offset it plus one extra to what it is. Does that make sense? I'm packing 8 to a byte. So I have to add an extra when it's not aligned. So 8 into 1. Oh, this is so confusing. At least the second part still works. So switch case is here. I think that's right. So now I gotta set those bits also. So 16 length. Offsetting at 1 from the head or the start. So it needs to set 6 bits. From the end of the bytes. Or the byte. Oh, I just don't. I'm just gonna try it till it works. Oh, I hate this. It was all working, and then I gotta add one extra thing. And it doesn't work. It's probably broken now. And I gotta like fucking fine tune it and check it. And then make sure it's like solid. So this sets which bits. And then I gotta like store, at least this is like the first byte. It's not though, it's position. Because I'm passing in a position as the first one. So I need to set the first position, which is 1. So I gotta save this value before it's modified. Oh, man. Like another property. but it also has to be scaled. So I want this one. Start position, shift it right to pick, divided by 8. So this is it. That's the index of the start. And it's const, so it doesn't change. So this is it. So I don't need this. Should rename to start. First, it's not the first index. It's not the 0th. So calling it a number. Oh, I get to find those also. Man. Oh, I gotta find those too. Man. Oh, this doesn't end. It doesn't end. This is non-ending. Oh, I gotta edit. Man. Why is it 6? Oh, it's inverted. So 6 maps to 1. Or 0. The start index should be 1. It's not 1. Of course it's not 1. I'm not paying attention. So I'm keeping the count if it's aligned, but losing the unaligned. So I gotta add 1 if it's not aligned. Oh, this is so boring. Freaking put here. It's const. And it's keeping all the bits above the line part. So yes. Is that it? Am I done? I moved the window, I didn't resize it. I just closed it. Why is it not clicking? God freaking fuck. I gotta. It says the case is 6. If it's entering, it should be fucking setting value. This is 6. So it should be setting 1 bit to 0. It's entering. Why is it not fucking... Now it sets it? Is this not the number 0? I just printed it. It said 0. Is this not 0? Or did I set it to 1? I think I set it to 1. But it should be 1. So it's overlapping. Alright, this is 1 then. Oh, this is annoying. I gotta adjust the last position again. Because now, this one is up 1. You know what? I'm just gonna do this offline. This is so boring. I gotta like rework this whole thing. Hooray. Yay. You know what's lots of fun? Assign values in JavaScript. Just so much fun. Oh, this is fucking annoying as fuck. I gotta go through top to bottom. And get this tiny thing figured out again. Oh, this is so annoying. Stream's at like 11 hours. So I'm like, finish this up later, whatever. There's no point in doing a second stream. YouTube, Twitch, fucking biased. So, I don't know, I'm gonna get further than stream again. And when I say like my JavaScript engine is faster than Chrome, I mean like it is significantly, it is so much faster. Like, it's not percentage, it's like times faster. Multiples times faster. Not like 10-20%. Like, times faster. And I have wasted my fair share of time in the browser. So it's not like I'm just like this grumpy idiot that's like, oh, I hate this stuff, it's dumb. No, it's like, I know exactly what I'm doing, and I'm gonna put Google out of business. Because their shit fucking stinks. Oh my fucking god, just work. What did they do to the mouse updates? The web browser has had 3D for so many years, and nobody uses it. Because it's so fucking... Do you know how much work it takes to make something 3D in the browser? To make a little like fucking sandbox. They can paste shit in to make 3D anything. And the work it takes to attach JavaScript to it. Like, do you know how much work that takes? Where the fuck is the box? It didn't set. What the fuck did they do to the mouse updates? God damn. Designing anything in the web browser is a fucking joke. And a waste of time. And I have the most complicated part, the JavaScript part, already done. I just gotta make it 64-bit from 32-bit. Because I thought 64-bit would die. like 9 years ago. Because 32-bit was faster, but apparently the like 10-20% speed difference, nobody cares. So 64-bit's still around. That's just stupid. Thinking 64-bit would die. It's definitely slower than 32-bit. And then the game engine I'm making, I'll be able to like simulate all this stuff in it. So I don't even need to make a web browser. I could just make nodes in the game engine and then end up with a browser. And then the website builder, I can like transpile between HTML or Tumblr. And like the whole thing, whatever. And then I can update the transpiler to work for like other things to transpile. That's where I like push the browser to the limit and it couldn't handle it, so I had to make my own. So all I gotta do is take all this shit I've already done and then make like the one like actual working web browser, art project, art program, whatever you want to call it, that doesn't exist. I could even make like Photoshop inside my game engine. Man, this shit's gonna be awesome. And it's funny to say that because it's like, most people are like, hey, it's just a couple fucking boxes, big deal. You have like a little node system. You can like convert languages. So I click build, this is like HTML. And I click this to switch to Tumblr. And then build again. Now it's like Tumblr markup. So most people are like, so what? Big deal. But the bigger picture, and what it can be applied to, and what I'm going to apply it to. I don't know, whatever. Make some awesome shit. Every single fucking thing that doesn't exist, I will finally have it. And I can also add like an actual level of like security on my shit. So you can like sell a product, and then as long as like the engine's secure, the game engine, anything on it should be secure. Unless someone hacks it, and anything's possible, except it's gonna be so difficult. So I don't know, whatever, what do I know? So I'm like, finish this up and I gotta read more into threads and shit like that. So I'm done for now. Peace. Web browser, garbage. Make a new one.